All right, let's start with the multi-threading concepts. So there will be a couple of theoretical behaviors, and I've created the files in front of me. So uh, codes rather, I will explain you what I'm trying to do. First, explain you the concept, and then show you a code of that, and then move forward. All right, should we start now?
Yes, I'm
All
ready.
right. Okay, great. Okay, so multi-threading, it means uh, you know executing multiple threads. That's a process in which multiple thread work simultaneously. Uh, Thread is a multiple thread would always run inside a process. What's a process? An application is a process by itself. So
Mhm.
any application can be considered as a process. For example, we are running SQL Server application. So that's a process by itself. Or we are running, let's say, a Notepad application. That's a Notepad process. It's a notepad.exe. If you go to Task Manager, for example, you will see that what are the processes running. You can see the process tab out here. You can see that Zoom meeting is a process running out here. You will see a Cisco WebEx process being run. Visual Studio is a process by itself. So you have threads inside a process. So this is considered as a thread, or this can be considered as a thread. All right. So no, sorry, this can be considered as a process. I'm sorry, extremely sorry. So this can be considered as process. And inside these Zoom meetings, you will have processes. You can have sorry, inside this process, you will have threads actually.
I see.
So inside this process called Zoom meetings is a process. You will have threads. It can be a single thread. It can be a multiple thread.
Mhm.
Right. So multiple thread basically is a concept where you run multiple threads simultaneously inside a process. And why it is required, it is basically a process to achieve multitasking. So multitasking is initiated by using the concept of multi-threading. And remember, threads always run inside a process. Process is equal to application. Now, what is the advantage of using multi-threading? It basically saves you time, as multiple tasks are being executed at a time. Okay. Now, to create a multi-threaded applications in C Sharp, we need to use this namespace called system.threading. Spelling is wrong, so I'm going to basically change the trip spelling out here. So we're going to use this particular namespace called system.threading. That's what you see out here. Let me try to annotate this. Yeah, this is the one.
Mhm.
Okay. And this particular namespace contains classes and interfaces. So any namespace, it's a basic rule in C Sharp that namespace will contain classes and methods, classes, interfaces, and classes will have members like your fields and methods. Okay, it can be a framework. So namespace can contain classes, can contain interfaces, can contain enumerations, can contain structures, etc. So this namespace basically a namespace to allow multi-threading concepts in our applications. So this contains classes and namespaces to provide facility of multi-threading programming. Now, this particular namespace also provide classes to synchronize the thread resource. The list of commonly used classes. So what are the list of commonly used classes? Thread is a class, mutex is a class, timer, monitor, semaphore, thread local, thread pooling, volatile. These are the classes inside this system.threading.
Okay.
And it is difficult to remember it, so don't bother about remembering these particular things. Don't worry about this. All right. So next part is I was studying about process and threads. So what is a process? Represents an app. It says that it represents an application. Process is nothing but an application by itself, whereas a thread represents a module of the app. If you consider the difference between process as well as thread, process is heavyweight component, whereas thread is lightweight. A thread can be termed as lightweight sub-process because it is executed inside a process. So a process will contain thread. Process by itself can contain multiple threads, but each thread will be a lightweight execution, whereas a process by itself is a combination of threads, and that's why process is considered as a heavyweight component and the execution may be heavy. So whenever you create a process, a separate memory area is occupied by the particular process, but threads share a common memory area. That's the beauty of it. So that means that when you create processes, each process is equal to an application. So they will have a separate memory allotted to it. Whereas the threads will be inside the process. So they will share a common memory area. By default, if you create multiple threads inside a process, multiple threads are not going to take individual memory space. Whatever process, whatever memory is allotted to the process, so that will be commonly used by the threads without using any extra memory space. So that's the beauty of it.
So I actually have a question about that.
Yeah.
So earlier you mentioned that each process has like it can have threads inside of it, multiple threads.
Yes.
So in that case, if each process is allocated its own memory,
Yeah.
is you're saying that those memories aren't protected or like they're not like they can the different processes can communicate not processes, the different threads can use the different memories?
No, I'm trying to say, for example, this is a process. Let's say this process called as notepad
Uh-huh.
.exe. So this is allotted, let's say, 15 MB of memory space, for
Okay.
example. Now this notepad is running multiple threads.
Okay.
Thread 1, 2, 3, for example. So these three different threads is not going to take extra memory space.
I
They're
got
going to work and use the same memory allotted to notepad.
I got it. That makes
Okay.
sense.
Yeah. Okay. Okay. Now so every thread has a life cycle. So should understand this life cycle, because it is important to understand this life cycle and how a thread works. So the life cycle of a thread would be started when you create an instance of the thread class. That's what I've defined out here. So life cycle of a thread is started when we create an object. Instance means object. So when we create an object of the thread class is present inside this namespace. So when we create an instance of the thread class, we start the life cycle of that particular thread. Okay. When the task execution of the thread is complete, the life cycle ends. Okay. Now these are the states or different states of the life cycle of a thread. So when is the thread life cycle starting? When we create an instance of the thread class. When we create an instance of the thread class. This is the instance. Okay. Now when the thread stops execution, okay, here when the execution of the thread ends, the life cycle of the thread will end. That's how it is. So between this birth of a thread is when you create an instance of the thread. And how do we create instance? By using the new keyword. And that's the class name. So when we create an instance of the thread, we have given birth to the thread cycle. And when the thread stops executing, that is where we consider it as the end state of the thread or the end cycle of this particular thread. So between this starting and ending cycle, there are certain states. These are the states. We have unstarted state, we have runnable state, ready to run. Running state, not runnable state, and dead state, terminated. Okay. So terminated means you are terminating the thread. It does not mean you are ending this thread. Ending of a thread is it's a very smooth process. You start a thread and you end a thread. Termination of thread does not mean you have ended the thread. It means that you have purposely terminated it, made it dead. So what is the unstarted state? When the instance of the thread class is created, it is unstarted by default. There are certain things which you need to understand. So when we create an object, when you create an instance of the thread, we say that it is an unstarted state by default. What is the runnable state? When the start method is used on the thread. So when the start method is used on the thread, it is a runnable or ready to run state. So if you want to run a thread, you have to use the start method. And when the thread starts running, or it is in ready to run state, we call it as a runnable state. That's the second. The third is your running state. This is the third one. Let's go to the third one.
So it follows.
So basically, running state is what? Once only one thread within a process can be executed at a time. Only one thread within a process can be executed at a time. At the time of execution, thread is in running state. It says that is a very important sentence. Only one thread within a process can be executed at a time. Okay. At the time of execution, thread is in running state. Not runnable state, thread is not in a runnable state. So if sleep or wait is used, sleep or wait method is called on the thread, or input output operation is blocked, we call it as a not runnable state. So not runnable state is a state when the thread is not running. Why the thread is not running? When we induce the sleep method or the wait method, or we basically block the input output operation of the thread. That is why it is called as not runnable state. Dead state, after completing the start, thread enters into dead or terminated state. All right. These are the cycles of the thread. It's not rocket science. You would be able to understand it. Any questions, you please ask me.
Right.
These are very straightforward.
So I could think of this as a state diagram.
No, it's not a state diagram. It's something like you have a bug life cycle. Have you heard of bug life cycle?
Not sure. I don't think so.
So at some point of time, when you find bugs, when you write your codes, you are doing white box testing. I do not know if you do white box testing or not. Generally, developers do white box testing. So when developers do white box testing, they find bugs. They do not call it as a bug. They use a term called as defect. Okay. These defects are reported in a reporting tool. That's called the bug reporting tool. Okay.
Okay.
This bug reporting tool will be reported with bugs. So this bug will go for a life cycle process. So that means there's a birth of a bug, and it stops with the death of the bug. So within this birth and death, there are different states. You have an open state when you're opening the bug for the first time, and then rectified state. That means it has been rectified. The bug has been rectified. Then there's a retesting state. So these are states between the birth and the death of the bug. And these states are implemented in the bug lifecycle, which is present in your bug reporting tool. So similarly, like your life cycle, for example, let's take a life cycle of human being. You are born a baby, then you become, a child, then you become adult, then you become, middle-aged, and then then you basically aged up, you become old, and then at some point of time, you're no more.
Right.
It's the same thing that is followed with your thread. So thread will also take a birth. All right. So it will take a birth, and it will also be dead sometimes. So when does it take? So when does it take birth? When you use the instance of the thread class. When does it die? When the thread execution completes. So between this birth and death of a thread, you have different states. For example, unstarted state. That means you have created an instance of the thread. Okay. You have created an instance of the thread class. So it is called as unstarted state. Then after that, you are doing a runnable mode. Runnable mode means what? When you use the start method in a thread, okay, it is called as runnable mode. Then what? Then third is a running mode. That means now the thread is running.
Right.
So thread is running now. After that, not runnable. When it does not run? When we use the sleep method or the wait method, it goes to a not runnable mode. Lastly, when the thread stops execution, okay, it is in dead state or terminated state. All right. So you can't compare it with the state transition diagram. Okay. But it's something like life cycle of a human being. Compare it with the life cycle of a human being.
Yeah, I guess it's more linear than a state diagram.
Yeah. Yeah.
Got it.
Okay. Okay. So let's understand the thread class. This is the main class. Now, the thread class provides properties and methods to create and control your threads. Now, where is the thread class present? Obviously, in the same namespace, and the namespace system.threading. All right.
Mhm.
So, what are the properties? So, let's understand the properties of the thread class. So, we have a current thread property. What does it do? It returns the instance of the currently running thread. So, it will return the instance or the object of the thread which is currently running. Give you the name of the currently running thread. Simple. Is
So
yeah.
in the case that you have multiple, I guess I might get ahead of myself, but if there are multiple threads, what does that return when you call current threads? Does it return all of them?
Return the thread which is running currently. You have 5 threads running. Now these threads will run one at a time. You will not basically see the time difference of how they're getting executed. So probably this will run first, this will run second. It is not that in the sequence it will run. Threads are always like that. It will
Okay.
run randomly. Okay.
Oh, okay, okay.
So
That
you
makes
cannot predict the running of the thread. So whichever thread is running at this instance, that thread's name will be called out.
okay.
All right. Now is live property. What does it do? It checks whether the current thread is alive or not. It is still alive or dead or terminated. Okay, it return true or false. It's used to find the execution status of the thread. Okay.
Mhm.
So is background property. What does this particular property do of the thread class? Used to get or set whether the current thread is in background or not. That means certain threads run in the background.
Right.
If I want to find out if a thread is running at the background or not, I can use this particular property. All right. So this is a property which will get the thread which is running in the background. You can also set a thread to run at the background. Remember, it's a get and set property. So getting the thread name which is running in the background or setting a particular thread to run at the background, both can be done by this particular property. All right. Manage thread ID. It is used to get unique ID for the currently managed thread. Okay, so it gets the ID of the current managed thread. Name property used to get or set. Set the name or get the name of the current thread. Okay. Priority property used to set or get, both set the priority and get the priority of the current thread. I can set that 1, 2, 3, 4, 5, 5 threads. I can set the priority of the threads. I can set the priority of this thread, this thread, this thread, this thread, this thread. So priority can be lowest, priority can be highest. Okay, I can set the priority, but there is a rider. I set the priority of a thread. It does not mean it will run on priority. You cannot control that thread. That is the problem. I can set the priority of a thread. Sometimes it will run on priority. Sometimes you will see it doesn't run on priority. So don't get worried up. That is how it works.
Interesting.
Okay. Thread state. It is used to return a value representing the thread state. What is
Okay.
the state of the thread?
Like
It
running.
returns a value.
Yeah, yeah, yeah.
All right. Similarly, these are the properties of the thread class. Similarly, you have methods of the thread class. That's the next slide. This is a list of important methods of the thread class. So abort method. What does this method do? Used to terminate the thread. It raises this exception. It will raise this exception.
Okay.
So if you use the abort method, it's going to basically raise an exception. It's basically used to terminate the thread abruptly. Interrupt the thread. used to interrupt a thread which is in wait, sleep, join state. Okay. So interrupting a thread which is in this particular state. So let's say this is thread one, this is thread two. You
Mhm,
have basically given a sleep, use a sleep method. I want the thread to sleep for 5 seconds,
mhm.
right? I want these are the two threads, for example. I want this thread to sleep for 5 seconds. So 5 seconds, this thread is going to sleep. All right. So during this wait or sleep behavior, if you interrupt the thread, this is the point as you interrupt the thread. That means it is in the waiting stage or in the sleeping stage. That is where you can interrupt a thread.
I
I
see.
hope I'm clear. All
So
right.
if it's sleeping, you can wake it up.
You can interrupt it. Yes.
Okay.
Next is join method. It is used to block all the calling threads. Used to block all the calling threads means what? For example, 1, 2, 3, 4, 5 threads are running. I have started this thread and I am joining this thread. That means what is going to happen. Now remember, I told you the basic funda is that this thread is going to run randomly.
Mhm.
Right? I don't have any control over which thread is running first. This thread is running first, then this might run, then this would run, then again this can run. Okay, now I can use a join method. For example, I use a join method on thread one. So what will happen is that thread one will completely stop from start to end. And then thread 2, 3, 4, 5 will run randomly. That is what a join will do. So if I use a join method on, let's say, thread one will start and stop executing. Then thread 2, 3, 4, 5 will run randomly.
Okay.
All right. Reset abort used to cancel the abort request for the current thread. Abort is to abort, which will raise an exception called thread abort exception. This is to reset the abort. Resume method used to resume the suspended thread. It is obsolete now. The method has been basically removed right now. It was earlier used. Okay. Now sleep method. Okay. You can give an integer value as an argument to it. You can see that.
Mhm.
Sleep method is going to suspend the current thread. So if you, let's say this is 1, 2, 3, I basically use a sleep method. That means I'm suspending it, suspending the thread to sleep. Nothing but it is not, I'm not stopping the execution. I'm suspending it to execute for 5 seconds or 10 seconds. So so I do not want to use the sleep. I want to resume it, but this method has been removed. Okay, so can't use that. So sleep method is used to suspend the current thread for the specified milliseconds.
Mhm.
All right. Start method, very important. It is to start the thread. Changes the current state of the thread to runnable state. Suspend. Suspends the current thread if it is not suspended. It is obsolete. This has been also removed. Yield method. They used to yield the execution of the current thread to another thread. So that means the result of one thread will go to as an input to another thread. That is what the yield will do. Is to yield the execution of the current thread to another thread. So whatever is the result of the current thread, that will be passed over to another thread. That is what yield method will do. All right. Any questions, Paul?
Um, I have an idea what the methods are. That makes sense to me.
All right.
Yeah.
So we'll see a main thread example. So the first thread which is created inside a process is called the main thread. So first thread is very important. You're creating a first thread which is created inside a process. That's called the main thread. It starts first and end at last. That's the behavior. Okay, let's see an example of it. Let's go. Let's open up Visual Studio. I hope I've opened it. I don't know. Yeah, it's open. And in what? Okay, I have in a different Solution Explorer. Okay, let's open a Vector Solution Explorer. open it from start. Save this. I have Visual Studio is installed in your system.
Yes.
All right. So this is the solution. It's the multi-threading. Okay. Now, interesting thing that I've done is for your own good or for your understanding, you can see that I have given the project's name. I've numbered the project names. You have multiple projects out here. You can see this. Okay. And I've basically given the project's name, let's say first underscore multi-threading. Then multi-threading asynchronous, synchronous, multi-threading static method, multi-threading with non-static methods.
Mhm.
Then we have the multi-threading performing different tasks on each thread. Then sleep method, abort method, join method, name property, threading priority. So based on the behaviors of the thread, I have defined the project names. That is for own analysis and it will make your life easier. All right. This is how I've done it. Okay. So let's basically make this first one as the starter project. Let's open this. Let's close everything. Close all tabs. All right. Okay, the deal is basically to show you the first thread which is created inside a process is called a main thread. It starts first and will end at last. Example of it, that's what I'm trying to show you. So here is basically the namespace that you have to add. It's called system.threading. All right. I have a main method inside a class called as program. Now, if you look at, I'm creating an instance of the thread class. The instance of the thread class is created by using the current thread property. Okay. It's a current thread property. And if you look at the current property definition out here, if you look at the current thread, returns the instance of the currently running thread. Current thread property will return an instance of the currently running thread. All right. This will return an instance of currently running thread. Okay. So I've used this property. The return type of this property is a thread instance, you can see. And then I give the name. What is the name property used for? Name property is used to get or set the name of the current thread. So I'm setting the name.
Right.
Okay. And then I'm basically printing out the name. So this will return an instance of the currently running thread. What is the currently running thread? Okay.
The main.
Return, and that name I have given. So without creating instance of the thread class, I cannot use the properties, the main thread name. And that will be returning it. So let's run it. Control F5. If it says this is the currently running thread, main thread. All right. Simple example.
So, if you didn't change the name, I'm assuming the
Okay.
current thread is the main method that's running. Public static void
Yeah,
main.
this is basically the set method,
Yeah.
and this is the get method. Now, if you basically understand, if I do, sorry, if I basically call the instance out here, t dot, you will get other properties. Is alive, is the thread alive? What is this going to return? This is basically going to return a Boolean value. You can see this. So bool. It's going to tell me if the thread is alive or not.
Right.
So bool b is equal to this. Sorry. Bool is equal to this. So I can basically use t dot is alive property. and I can basically do a right line B. Is this thread alive? Then I can basically also find out uh, T dot, is it a background thread? You can see this. Return type of the background property is equally a Boolean value. So bool C is equal to this. And I can basically find out if this is a background thread or not. So without creating an object of the thread class, this is the way to create it. Okay. I will not be able to use any of the properties or methods. That's very, very basic behavior of object-oriented programming. You can say it is the thread alive? Yes, the thread is alive.
Okay.
Okay, and you can also see that is the background thread false. It's not a thread which is running at the background. Okay. It's false. What's the name of the thread? The name of the thread is basically, this is the name given, setting the name.
Okay. Okay, that makes sense. So this one is newly created.
Is it fine now?